So, welcome to this first session in the CCNA class. And this is, I say it as a first session. This is not a demo session. I have already covered the demo session earlier. So, if you would like to know what will I be covering in the CCNA, what are the topics that I will cover as per the CCNA course, I will mention the demo link on the chat soon before I end the meeting. Please go ahead and watch that video. And in today's class, I'm directly jumping into the CCNA's first session today. Okay. And in today's session, we will be discussing as the very first layer of the whole OSI layer model. And if you are not aware of OSI layer model, it's okay. I had just given a brief about it in my demo session. You can go back to the demo session and view that. But I'm not going into depth of what is OSI, how it works. As the course goes on, you will understand where are these technologies being used in the OSI layer model. Okay. So starting with today's class, and that is how are we surrounded by internet in our daily lives, starting with the physical layer. Okay, that is the lowest layer in the OSI layer model, the physical layer or the layer one. That's what we call it as per the OSI layer suit. Right? And in most of the scenarios, what we would see is in our home or in our office or anywhere else. Okay, in the office side, we will mostly see where there is a PC, right? And that PC is connected to an Ethernet cable and it would be connected to a switch. The only visibility that you will have is your PC, the wire, and the switch that it is connected with, like this. Okay. And beyond that, how that switch is connected to the internet, how you are indirectly connected to the internet, you are completely unaware of it. And basically, that is what the study of computer networks or CCNA, CCNP, or CCI is all about. Okay. So you would have first seen that, or likewise here, I am sitting on my laptop. Okay. And I'm connected to a Wi-Fi modem wirelessly. Okay. If you're connected to the session on a mobile phone or again a laptop, you would be connected to a wireless medium, and that wireless medium is sending wireless signals to your Wi-Fi modem, and that Wi-Fi modem is again connected to a cable. In today's world, this diagram is a pretty old one. It's called as DSL. Okay. In today's world, even in today's internet, if anyone tries to get an internet today, this Wi-Fi modem would be connected through an optical cable or fiber cable. So what happens is that the visibility that we have is only limited to this. Even as network engineers, okay, the visibility that we have, I mean, physical visibility where I can feel and touch the devices, the cables, okay, is only limited to this part. Okay. Me being a service provider network engineer, I do not know I cannot feel what is inside the internet. The only thing that I can do is I can just view it through a software. That's all. So that's the very first thing that we ever come across. The first thing is a PC or a laptop. Again, these are networking devices. The cable that you are connected to the switch, or your Wi-Fi adapter, right, which is sending wireless signals. These are the mediums that you usually come across every single second of your life, right? And why am I talking about this? You'll understand in a bit. Okay, so this is one of the common scenarios or common topology that you will always see in the network. Another common topology that you would always see is a small office. Okay, a small office where you can, as per this diagram, you can see there are a couple of PCs and a printer which is connected to a switch. What is a switch? How it forwards data, how it receives data, everything will be covered in later sessions. But for now, just understand how things are working and how do you usually see it. So you would mostly see that there are a couple of computers where they are connected to through wire and they go to a switch. And this switch is then connected to a router. Again, router is a device. We'll discuss about router in depth later. Okay. And then this router takes you to the internet. Okay. Now, this is one example. Another example of a similar kind of setup is a jewelry shop. Okay. You think of any jewelry shop in South India, mostly Kalyan Jewelers, even in India, Kalyan Jewelers, Tanishq, they are very famous. Okay. So in a jewelry shop, you can see a lot of video recording devices, especially those security cameras. Okay. Think of these PCs as security cameras and this printer here as the cashier who is sitting here. Okay. So what happens is that these video cameras, okay, these cameras, they are recording, obviously, because it's a jewelry shop, they need a high quality video recording. Okay. So I'm just taking a 720 pixel video recording that they're doing. Okay. So a 720 pixel video camera that is being that is recording, and it is recording 24/7. Okay, imagine in just a 720 pixel video camera, one single camera in 1 hour with a 720 pixel, I think it can go up till probably 500 or 600 MB of data in 1 hour. We have 24 hours and it runs it in every single day. So the imagine one single camera recording such huge amount of data, right? Obviously, you cannot store it in a local CPU. It needs a huge it needs a huge ROM or a storage capacity, right? And in a jewelry shop, there's just not one single camera. There are 20, 30, 40 cameras, and all of them are sending huge amount of data. Storing it inside the jewelry shop is not going to work. What do you need? You need to send that data to the internet, where in the internet we call it as a cloud storage. You store all those recordings in the cloud, and whenever you need it, you can access that video and preview it, right? So again, this is a kind of setup that you may see, okay, which is called as a small office setup. Okay. Now, usually these switches in such scenarios are called as unmanaged switches. They're called as unmanaged switches. What do we mean by unmanaged switches? Okay. Again, as I said, we'll discuss how switch forward data, etc. later. But just understand what do we mean by unmanaged. Unmanaged meaning you cannot manage it, you cannot control it. It is the vendor, whichever switch you buy. You can buy a Cisco switch, you can buy a Juniper switch, you can buy a Nokia, Aruba, Arista, any switch that you want to buy, you buy. It's called as unmanaged, meaning the vendor or the manufacturer has already programmed it. You cannot control it. He has already programmed it. And what you're supposed to do, you're just supposed to plug it and play with it. So you will have a power cord which will be connected to a socket. You can connect it to a socket. Okay. All you need to do is just power it on, and the pre-program that the vendor has done, it will start running. So what happens when an unmanaged switch is that all it does is it will capture the data that is coming from all the devices or all the cameras, and it will send it to the internet. It will also do the same in the reverse direction. Okay. Where we may see this in the reverse direction is in an internet cafe. Okay. In an internet cafe, obviously the internet cafe is connected to the internet. Okay. The internet cafe is receiving data from the internet. It comes to the switch, and that data is then forwarded to all the PCs that are connected to the switch. That is how you are able to access internet in the internet cafe. Those switches are called as unmanaged switches, where you cannot control the working of a switch. Managed switches are those switches where you can control the working of the switch. Okay. So in small offices, we usually go for unmanaged switches because they're cheaper also. And probably I would say they are dumb. Okay. Basically, they are dumb. All they are doing is just receiving the data and forwarding it. That's all they do. Okay. That is why people prefer in such scenarios where all you need is forwarding the data to the internet and receiving the data from the internet, we usually use unmanaged. They are cheaper. They are they can do, or they can, you can make it work based on your requirement, okay, for small purposes. But if you want switches, in a big company like ours, Cisco or Juniper or Google or a big corporate office, you need managed switches. And how managed switches work, or how they are connected? They are connected like this. This is just a sample diagram. You may see a different kind of connectivity in real time, but this is just a sample diagram. So you can see here, this is a building and it has different floors: first floor, second floor, third floor, right? So you can see in the first floor, there may be one PC, there can be multiple PC. Okay. All these PCs are connected to a wire to a switch. And if there are users who are using laptops or mobile phones, they are connected wirelessly to a Wi-Fi modem, and that Wi-Fi modem is connected to a wired interface or a wired cable to a switch. The same kind of connectivity, you can see it on the first floor, second floor, and the third floor. Right? Now, all these switches in different floors are then connected to a centralized switch. This centralized switch is only one or two or three in the whole building. Depends on the number of switches you have in the company. Okay. If you have more number of switches, you need more number of centralized devices. And all these centralized switches need to be interconnected again. Okay. So all these switches are then connected to a centralized switch. This centralized switch is then connected to a router. That router takes you to the internet. Okay. So you may see this in a corporate sector, big companies, okay, or even in a shopping mall, you may see this. Right? Then, since now we are talking about connectivity, right? I'm saying that these pieces are connected through wired cables to a switch. These switches are connected to another switches, another centralized switch. This switch is connected to a router. Router is connecting to the internet, etc. But how are these devices connected? Obviously, these devices are connected through a wire. Okay. So there are different types of wires. And these are the types of wire. And again, these are not from a memorization point of view. These are just from an understanding point of view. Okay. You do not have to memorize. I've just given you just for understanding sake. Okay. So there are different types of wires. Okay. And based on their speed, they are given different names. So the most common wire that you will always see in a network is a fast Ethernet wire, whose speed is 100 Mbps. Okay. And as per the IEEE name, IEEE stands for Institute of Electrical and Electronics Engineer. Okay. They are a professional company who, I'm pretty sure in the college days when we are supposed to submit projects, our teachers or our professors say the project should be in IEEE format, right? So IEEE has set a standard or a format. Similarly, for wires also, IEEE has set a standard name. You can see these are the standard names based on the speed of those wires. So you have a 10 Mbps, that is the lowest, which is called as an Ethernet. Then you have a 100 Mbps, which is called as a fast Ethernet. Then you have a 1000 Mbps gigabit Ethernet. Okay. Then again, you have a 1000 Mbps gigabit Ethernet, then 10 gigabit or 10 gig Ethernet. Now, these wires also have length, obviously, right? If there is a wire, that wire obviously will have a length. Okay, starting from one end to the other end, it should have one length, right? So again, these wires are copper wires. The copper wires have length of 100 meters. You can see all these copper wires have length of 100 meters. The only wire which has a higher length is the fiber wire, which has a length of 5 kilometers or 5,000 meters. Okay. And you can see, though the speed of that wire is 1000 Mbps, the IEEE name is different. 1000 base LX. This 1000 base copper wire can carry data only up till 100 meter, but this fiber wire, which has a speed of 1000 Mbps, can carry your data up till 5 kilometers. That is why you can see in today's network, we will mostly see fiber cables being incorporated or being connected together rather than copper wires. Copper wires are mostly seen in the corporate side, a small area. Mostly in our offices, different switches are connected through copper wires. Okay. And how are these copper wires? How do these copper wires look like? Okay. So there are different types of copper wires. I'm not going much into detail. Okay. Before I go, is there anyone from electronics or electrical background in college? Is there
Yes.
anyone?
Yes.
Yeah. Right. So obviously, you would have seen like we have different types of wirings. Right. We these are called as twisted pair. Okay, twisted meaning they are twisted. You can see they are twisted. Pair, you have two set of wires. Okay, so there are two types of twisted pair wires. One is an unshielded twisted pair, and then there is a shielded twisted pair wire. Okay, what is the difference between these two? It just means unshielded meaning it does not have a protective covering like this. You can see copper shield, plastic cover. In an unshielded twisted pair, you will not see such kind of covering. If there is no such type of protective covering, you may see a greater data loss. Okay, so if if you step on the wire, okay, and if you rub the wire like that, your data transmission will break. Such kind of things are there. And there is another called as shielded twisted pair, meaning you have some kind of protective layering. Okay, the working of both the twisted pair is same. How are they working? You can see twisted pair, you can see they are in a twisted manner, crisscross manner, and pair meaning you have two wires. Okay, so imagine this part as one end number one of the same wire. These are the same wire. This is one end, this is the other end of the same wire. Okay, imagine like this. So this is end number one, this is end number two, and this is the wire that we're seeing here. Okay. So what is happening in twisted pair? Again, these are not important from a memorization point of view. It's just how wirings are working in networking. We have to understand. And these are mostly used if you are a hardware engineer. We all are network engineers. There's no need for us to memorize all this. Hardware engineers, field engineers who usually come to install Wi-Fi in your home, they need these knowledge. Okay. So anyway, in twisted pair, what happens? You can see one end is transmitting, that same end would receive on the other side. On the other end, this end is transmitting, this end would be receiving. So you can see this diagram. This node is transmitting, the other side is receiving, the other side will transmit, this side will receive it. Usually that's how copper wirings are usually twisted and made. Okay. One side, one part of the wire, one wire in the pair will transmit, the other side will receive. On the other side, the other will transmit, here the side will receive. Okay, it's again from not from a memorization point of view, but for an understanding point of view. Okay, so as I said, this is the most common wires that you will see across your small network. That is the RJ45 connector. Okay, the wire is not called as RJ45. It's just a normal wire. It can be an UTP, that is untwisted pair cable, or an STP, shielded twisted pair cable. It can be any kind of cable. Okay, but the connector, this the head of the wire is called as an RJ45 connector, and this is what we commonly see in the server rooms, even in the laptops. Nowadays, even in older laptops, we had this RJ45 connector. Nowadays, we don't have that. Okay, in if you're using Mac, you will not even have a USB. You'll just have a CPO. Okay, so forget Mac. Anyway, so These heads are called as RJ45 connector. And these RJ45 connector, as you can see, they are connected at the end of these, at the end of at the end of the wire, the two ends of the wire. Okay. And how do you connect? In your laptop, on your devices, networking devices, routers, switches, or anything, networking devices, especially, you will have an RJ45 port. And what you will do, you will connect this head to the RJ45 port of your device. And the other end or the other head, you will connect it to the other side of the device. Okay. So this is, for example, PC number 1. This is PC number 2. You can connect the two PCs using an RJ45 connector and connect it using a cable. Okay. Now, I just simply mentioned you can connect. If you have a wire, if you have a wire with RJ45 connector, you can just simply plug it into the PCs and it will start working. That's what I said. But no, it's not as simple as that. Okay. You need few more things in order to connect it. And that few more thing is called as a network interface card. Okay. Network interface card. So before I jump into what is network interface card, etc., has anyone ever drilled and hammered a nail in a wall? Has anyone experienced drilling and hammering a nail? Or has anyone, obviously, you would have seen someone drilling and hammering a nail? How
Yes.
many of you? Yes, right? So, what happens here is that when you drill, it makes a hole based on the length of the like your requirement. You put a needle and you drill a hole in the wall. Okay. And you cannot just simply put the nail and hammer it. It will just fall off. The nail will just fall off. So what you do, you usually put a wooden piece or you put a plastic piece into the hole and then you hammer a nail, right? That is how drilling and hammering a nail happens. Similarly, when you buy a switch, if you buy a PC or anything, okay, and if you want the RJ45 connector, okay, to be connected to the device, you the company has already drilled. You can see this switch. Okay, it's a Catalyst. I just googled and found this picture. You can see this is a Catalyst 3560 Cisco switch. So what the companies do is company has already given you or drilled a hole into the switch, but you cannot connect the wire. To connect the wire, you need that wooden piece or you need that plastic piece. That wooden piece or that plastic piece is your network interface card. All these interfaces you see or all these ports that you see in the switch have a network interface card behind them. Okay, so basically what is happening, these network interface card these network interface card are that wooden piece or that plastic piece, okay, which you insert inside the chassis of your switch, and then you plug your cable into it. Then you plug the cable into it. Okay. So network interface cards are built in smaller switches like this Catalyst 3560 switch. The network interface cards are already built. But if you go to higher end switches or higher end routers, these network interface cards are given on paying basis. Okay. So if you have a high or a big server or a big router, okay, but for your requirement, you do not need all the interfaces. You do not need all the holes. So you are not going to purchase all the interface cards. You will only purchase interface cards as per your requirement. Okay. So the bigger the switch, the empty your chassis will be. And based on your requirement, you will have to buy the cards and then fix it. Okay. Any question here? Anyone?
Yes, Laksh. I have two,
Yeah,
like there are two kinds of switch. Like one is managed and the other one is unmanaged.
correct.
So what are the difference between managed and unmanaged? I understand that unmanaged is plug and play.
Hmm.
Sorry, managed is nothing but plug and play. So what is unmanaged? So how different it is from managed?
Okay,
What are the features?
you got it the other way. Unmanaged is plug and
Yeah, yeah, sorry.
play. Okay, unmanaged is plug and play.
Yeah, managed.
Managed is, yeah, in managed you can configure the switch. You can configure VLANs, you can configure IP addresses, you can configure protocols, etc.
So all those things will come in the next.
Yeah, yeah. All those things will be studying later.
Got it. Okay. And coming to this, our current topic, like network interface card. So
Hmm.
what are the features?
Features again,
Why
it,
exactly do we use this in the network? Yeah, NIC.
yeah, Nick, NIC. Okay. So you see this when you buy a switch. Okay,
Hmm.
when you buy a switch, basically what happens is, you, as I said, you need this cable to be plugged into these ports.
Correct.
Okay, and what happens is that these cables will be sending data, electric pulses. They will be sending two electric pulses. They will be sending data. Okay, and once you connect those wires into these interfaces, there should be something else which can collect those or read those electrical pulses, right?
Mm-hmm.
So you need these cards, interface card which has all the electric circuit boards. Okay, these electric circuit boards will be behind these interfaces, like this,
Okay.
connected. So you plug, and basically you will be plugging the wire into here.
Got it.
Okay, so whatever data you send, these chips or ICs, they will be reading all that information and showing.
Okay. Got it. Got it. Sure.
Okay, anyone else, any question?
Thank you, Laksh.
Yeah, no problem. Okay, moving on. So why is the understanding of these cable necessary? As you can see, as I shown you here in this RJ45, you can see these golden things, right? These golden things are nothing but the copper wires. Okay, let me Google it and show it to you. Uh,
Laksh, on
yeah.
just I have one doubt. You
Hmm.
said that optic fiber cables, like, but those are usually are not used inside the home or offices. Those are like just to get the datas from the source. Like for the long distance, they use optic fiber, and they
Yeah,
make
yeah.
use of copper cables more within the smaller network so that the data transmission is fast, because in
Mm.
optic fiber it is also one of the disadvantage of it being is it is very difficult to connect, right?
Yeah, yeah, because you need the right amount of splicing, etc.
Yeah,
All that thing.
and the
Yes,
precision is required and everything.
correct,
I
correct.
know this because I had worked as a design engineer. I used to
Oh,
design
nice,
these
nice,
cables, so
nice.
I was a bit confused that nowadays do they use it within the premises as well?
Uh, they may use, they may, again, it based on the requirement. See, if you need a faster connectivity, you need higher bandwidth, you need higher speed, you will use fiber cable rather than copper cable. But if your requirement is just data transfer and you are okay with slowness of data, you will use copper wires. Okay, so in our homes we my internet speed is 60 mbps, and I still use fiber cable. Okay, why? Because if I can change my plan, I can change my plan to give me a speed of 200 mbps. Okay, for a 200 mbps speed, I need a better cable. Okay, for a better cabling, the internet service provider would suggest me to go for a fiber. So it is again based on my requirement. As since you know you are from a design point, based on the requirement we use the cablings. Okay, if it's just from my PC connecting to different other PCs through a switch, and data speed is not uh,
Constant.
constraint, is not a constant, I would go for a copper cable rather
Oh,
than a fiber cable.
okay. Thank you.
Yeah. What was I saying? Yes. So as I was saying, these cables, okay, these cables have be it a twisted pair or be it I'm talking about a copper cable. So these are the copper wires that you would always see, and these are the copper wires you can see here, the golden, these golden color. These are the copper wires. Okay, and through these copper wires are your electrical pulses being sent between the two devices. It can be a PC, it can be a switch, a router, anything. Right now, why is it important to understand? The reason is you can see these are copper wires. Okay, now there are two types of RJ45 cables. One is a patch cable, or it is also called as a straight through cable. The other is called as a crossover cable. Okay, straight through cable and a crossover cable. Now, before I jump into the technical details, let me first explain you. A straight through cable is used between two different types of devices. Okay, here you can see in this example, this is a PC and this is a switch. These are two different types of cables. Sorry, different types of devices. There we are using straight through cable. Different devices, straight cable. Okay, and you can see here these are same devices. This is a switch, this is a switch. In the same, when we are using same switch, when we are trying to connect same switches, we will use an Ethernet or an RJ45 crossover cable. Now, why is this important to understand? Okay, the reason is, think from these two switches. They are from the same vendor. Okay, not even from same vendor, different vendors. The switches are designed in the same way. Their motherboards, the way they work, obviously, be it a Lenovo laptop or be it a Mac laptop or be it a HP laptop or Intel laptop, anything, the working remains the same. Correct? Obviously, the pin cabling, the pin numbers, the capacitors, okay, the way the your electrical pulses are going through your ICs, all of them remains the same. The only thing is based on the capacitor, resistance, diodes, etc. The speed and all may vary, but the cabling or the pin points, the pin numbering remains the same. So in an RJ45 connector, you will always see 8 pins. You will always see such 8 pins. These 8 pins are used to transmit data and to receive data, both. Okay. Now think from a same device point of view. Switch number 1 here and switch number 2 here will have the same kind of pin numbering in their ports. Ports meaning these ports. These ports. Okay. They will always have the same kind of numbering in their ports. Okay. Now, if on switch number 1, I'm using a RJ45 cable to connect these two switches, right? So what is happening if on switch number 1, if using the RJ45's pin number 1, or yeah, here pin number 1, the data is being transmitted. Similarly, on switch number 2, okay, the pin number 1 would be used to transmit data. Okay, if pin number 2 is being used to receive data, on switch number 2 also pin number 2 would be used to receive data. So what is happening? If switch number 1 sends the data, it can only send the data. Again, switch number 2 will try to send the data. There will be a collision. Both of them cannot send the data, nor can they receive the data. Okay, that is why on same switches where the pin numberings are same, we use a crossover cable, where here you can see pin number 1 is being used to transmit data, but on the other end of the RJ45 cable here, which gets connected to the switch number 2, pin number 3 is used to receive. Here on the other side, pin number 1 is used to transmit data. On the other side, pin number 3 is used to receive data. Similarly, here pin number 8 is used to transmit data. On the other end, pin number 5 will receive the data. Here 8 will send the data. Pin number 5 will receive the data. So what is happening? The pin numbering and here the pin numbering on the same devices are same. That is why we need two different pins or pin numbering or pin positioning to transmit and receive data. So here it would make more sense. Pin number 1 transmit data, pin number 2 receives the data. On here, pin number 1 transmit the data, pin number 2 receives the data. Okay. Using this same logic, let's go to the upper diagram where different devices. This is a PC, this is a switch. The pin numberings where they receive the data and they send the data are different. So here PC number 1 will use pin number 1 to transmit data. Switch number 1 there will use pin number 1 to receive data. 2 will use to send data. Here receive the data. So different devices, straight through cable. Same devices, crossover cable. It is only because of how the pin numberings in their interfaces as well as on the RJ45 cable is designed. Okay. Any question understanding straight through and crossover? No? Good. Thanks.
So let's, yeah, I have a question. So these switches, right? Is it common, right? So suppose you said that 1 and 2 transmit and 3 and 6 are receiving it. So will these port numbers be standard across all switches, or is it specific to some models?
No. It is no. It is specific. No, not specific. It is a standard. It is a standard. So you can see here this diagram crossover cable. Okay, 1 will transmit, the 3 will receive it. Okay, 1 transmit, 2 is transmitting here, 3. So yeah, crossover cable you can see 1 and 3 is the same. This 1 and 3 here, they're always paired. Okay, so what happens is this is the let's say this is RJ45. Okay, on the other end also this is the connector. So here 1 will be used to transmit on the same cable. Here pin number 3 will be receiving that data.
Okay, I got the
So
point.
it's a standard. It's a standard across.
Okay, any node with RJ45 ports will follow the same standard.
Correct, but you have to again specify. You need a straight cable or you need a crossover cable. So the numberings would be the pin numberings would be different.
Okay.
So here is just a diagram of how things are connected. So you can see these are different switches, switch 11, 11, 12, 21, 22. You can see these are same switches and they are connected through a crossover cable. Okay. And you can see this is a switch, this is a PC, and they are connected through a straight through cable. Different devices, straight, same devices, crossover. Right. Now, we have been talking about copper wires. So copper wires use electrical pulses or electrical signals. Similarly, we have fiber cables which use light, right? Which use light. And fiber cables have a much more protection. You can see here, this is just a sample diagram of how a copper wire, not copper wire, sorry, fiber cable or an optical cable looks like. Okay, you have different layers of protection. Okay, and this last layer, that is the core, this is through where your light signals are passed. There are two types of light signals. One is an LED, the other is a laser. Laser is more focused. Okay, the light that is sent is more focused. Okay, so your speed is more. Okay, speed is more, and it can even go at a higher what do you say, distance. While sending data through an LED needs lot of reflection and refraction, which then creates a lot of delay. Okay, which creates a lot of delay, and you can also see that because you can see the difference in the manufacturing. Here you can see these are different layers in the optical fiber cable. You can see the cladding layer. The cladding layer here has a lesser width, whereas in the uh, uh, what do you say, laser one, the cladding, I forgot the actual name for this. Probably I'll share it with you tomorrow. I forgot the actual name for such different optical fibers. In the second diagram, you can see the cladding has a more width. Okay, the core has a lesser width because you can send only one single light stream or a light pulse, one single light pulse. With an LED kind of in the upper diagram, you can send more number of different data or different light pulses.
Laksh, I think it is single mode and multi mode.
This is a single mode, if I'm not wrong. Is this
Huh.
single mode? Okay, single mode and multi mode. Okay, again, the name, thank you. The name already defines. Single mode meaning you can send only single light pulse. Multi mode meaning you can send multiple light signals. Okay, if you're sending multiple light signals, you need a wider core which can send or accommodate different light pulses and it can travel. Single mode, you can send only single light stream. And again, just like your copper cable, you have different optical cable IEEE standards. Right? So you have 10G base, S, LX4, LRE. Again, these are based on the distances that they can go. Okay, so it can carry, the first one can carry the data up till 400 meters, the other is 300, the other is 10, the other is 30 kilometers, etc. So based on your requirement and based on the distance between the two devices and the cable that you have, you can use different cabling structures or optical fibers. Now, any question? Because now I think physical layer is over. There's nothing much to study in the physical layer, because physical layer, when we study physical layer, we are studying the hardware engineering. Okay, and the CCNA, CCNP or CCI is not from a hardware engineering point of view. It's from a software network engineering point of view. Okay. Any question up till here? Okay. So moving on to the next layer, which is called as the layer 2. Layer 2 is also called as the data link layer. Data link. Now, whenever especially me, whenever I think of a data link layer or layer 2, the first thing that comes into my mind is the device called as a switch. So you can see there are I have given two different diagrams. One is a switch manufactured by Cisco, and we have different switches manufactured by Netgear. Right. So switches basically looks like this. You have different types of switches. You have a single chassis switch. You have a multi-chassis switch, etc. Okay. So single chassis basically means this is just one single box, or it's also called as a pizza box. It's also called as a pizza box, right? So again, this particular switch that you see of Cisco is of a higher end side. The picture that we saw earlier, this is a simple switch. Okay, it can be used in home, it can be used in small offices, etc. But such switches is usually used for a higher purpose. Higher purpose meaning higher data transfer or higher load. Okay, so this is one higher end switch, and you can see there are different types of such switches from Netgear. So the first switch you can see is the most common type of switch, which is again called as an unmanaged switch. As I said, it's called as a I would call it as a dumb switch, because all it does is it will receive the data on one interface and it will forward all the data to other interfaces and the devices that are connected. That is how basically an unmanaged switch works like. The rest of the switches that you see are called as managed switches, where you can, as I said earlier, you can manage, meaning you can create VLANs. We'll talk about VLANs in future classes. VLANs, you can create spanning tree protocols, you can create IP, you can create Ethernet, Ether channels, etc. All that. Okay. So basically, this is how a switch basically looks like. And all these you see, all these small holes that you see are called as interfaces. They're called as interface or ports. Both these names are used interchangeably. You can call it as port or you can call it as interface, anything. Okay. And again, these are like, I'm not going into the hardware point of view, what are the different types of port, etc. Okay, because that comes again from a hardware engineering point. But if needed, when we are doing the practical, I will show you, or I will tell you how to connect to a switch, or and how do you log into a switch. And that discussion is in the later point, at a later point. So anyway, using these switches, I have been saying that we connect different devices to the switch. Okay, and two different switches can be connected. The switches can be connected to a router, then the router is connected further to the internet devices, etc. How were they connected? And this diagram basically gives us the exact idea. So you can see there are two switches, switch 1 and switch 2, and these are small interfaces which are just diagrammatically given. And you can see different PCs and different servers, etc., and even two different switches connecting together through the interfaces. Okay. Now, till now, I have been always saying that forwarding data, they will forward data. Cables, they forward data, they send data, or optical fiber, they send data. Okay. In any networking device, okay, in any networking device, if it needs to send a data to someone else, for example, let me say this is me, okay, this is me, and this is my friend. Let's check from a real time perspective. I want to send him a letter. Okay, if I want to send him a letter, obviously the first thing that I need is his address. I need his address, then only I can send him that letter. Okay, now what would happen? I would write his address, which is basically unique in the whole world. My house address is obviously unique in the whole world. Okay, my neighbor's address and my address are unique from a flat number point of view. I live in, let's say I live in flat number 101. My neighbor lives in flat number 102. Okay, again, there is a difference. My flat number is different. The rest of the address may be same, but still there is a uniqueness in my address. Similarly, the address that I write for my friend is unique. Now what happens? When I send this letter, what happens? Imagine this as post office number 1, and this as post office number 2. So what happens? This address goes to the nearest post office. Okay, the post office or the postman, he reads the address, and then he sends this letter to the next post office or post office number 2. The postman in the post office number 2 then takes that letter and delivers it to my friend. Correct? Similarly, in your networking, all your networking devices, it can be your PC, it can be your laptop, it can be a switch, it can be a router, it can be a server, it can be even your smart TV. Okay, all of them, they require an address to send data and to receive the data at layer number 2. At layer number 2, they need some kind of address to send data and to receive data. And that address is called as a MAC address, which is again unique. Every networking device in this world has a unique MAC address. My laptop's MAC address is unique. No other device in this world will have the same MAC address as my laptop, or for that matter, my phone or my smart TV or anything else. All of them will have a unique MAC address. Okay. So how does a MAC address basically look like? We know that our letters, whenever we write a letter, we have a flat number. Okay. Flat number, then building number, if ever we need a building number. Okay. Building number, then or building name, etc. Then we have a society name. Okay. Society name, then area. Okay. An area, then city. Then we write the state. So basically, this is the format of our address. Okay. This is basically the format of our address. A similar format, not exactly the same, but a similar concept is given in a MAC address. And how does a MAC address look like? Let's check that. So you see, this is how basically your MAC address would look like. I hope the font is okay. Do you want me to increase the font? Let me know. Is this font okay?
Yes.
Yeah, thanks. So this is what your MAC address would look like. Okay, 0002171710660. Okay, and as I said, this MAC address is unique to whatever device this is associated. Okay, and as far as I know, okay, as far as I know, the current world population is, I think, around 9 billion. If I'm not wrong, is around 9 billion. Basically, that is around 900 crores. Okay, so as I said, unique. In my home itself, okay, we have 4 phones. Okay, we have 4 phones. They need MAC addresses. We have 2 laptops. They need MAC address. We have 1 smart TV that needs a MAC address. Right. So what is happening? In one single house, I need 7 MAC addresses already. There are 900 crore people. Obviously, not all the 900 crore people are using networking devices. Let's say 800 crore people are using, or 8 billion people. Okay, 8 billion people are using networking devices. Those networking devices can be phones, laptops, smart TV, IP phones, IPTV, etc. Anything. For 8 billion people, if I want unique MAC address, how is that possible? Okay, now before I jump into that discussion, let me tell you about something about MAC address. MAC address is a 6-byte number. Okay, 6-byte meaning 48 bits. Okay, so here the MAC address that you see, if you convert all these digits into their respective binary number, they will be 48 bits long. This MAC address will be 48 bits long. So using 48 bits, how can I create how can I create how can I create unique MAC addresses? Okay, so let me also show you the MAC address that is on my PC. To check the MAC address of your PC, all you need to do is IP. This is on Windows. Okay, I'm not sure about the Mac. Okay, so you can see. Okay, MAC address is not here. Okay, MAC address is not given here. Anyway, no problem. Let me open Wireshark and show you. So as you see here, this is my MAC address. This is my MAC address, 70B64F 60A346. This is my MAC address. Okay. So again, you can see these are in alphanumeric from a human readable point of view, this is alphanumeric. You can find numbers, you can find alphabets as well. Okay, but from a from an engineer's point of view, we cannot call them as alphanumeric. They are called as hexadecimal. Okay, they're called as hexadecimal. So 48 bits. If you convert IP config space all is do we have a space, Ganesh, in between?
Yes, space is there.
Yeah. So this is my Bluetooth MAC address. Okay, you can see I have different Ethernet adapters. Okay, you can see there are different MAC addresses for all those. Thanks, Ganesh, for that. Okay, so with this you can check the MAC address of my device. Okay, so if I have a VMware virtual Ethernet adapter, for that I have a different MAC address. So you can see already I have different MAC addresses for different ports of my computer. So similarly, even your NIC cards, the NIC cards that we were seeing earlier, they have different MAC addresses. We have 8 crore devices. We just have 48 bits. How can 48 bits give unique 8 crore MAC addresses? That is what we are going to check now. So let me write down 4 digit binary numbers, okay, up till 15. So 0000001, 0010, 0011, 0100, 0101, 0110, 10. 1100111011110. Okay, so these are the binary numbers, 4-digit binary numbers. And whoever is not from an electrical or electronics background, these are binary digits. We know that binary numbers can be only 0 or 1. Okay, 0 or 1. So you can see only zeros and ones here, no other digits. If you convert it into their decimal format meaning numbers like 1, 2, 3, 4, 5, 6, etc. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, we go only up till 15 decimal point. Okay, now what is hexadecimal here? Okay, I will not go into technical detail of what is hexadecimal, etc. Just remember, in hexadecimal, the numbers from 0 to 9 are written just the same: 6, 7, 8, 9. Then 10 onwards, you do not write them as 10, 11, 12, 13, 14. You write them as A, B, C, D, E, and F. Okay, so these are the hexadecimal values for their corresponding binary numbers, 4-digit binary number. So the MAC address that you see here, 70B6, okay, you need to convert them into their respective binary numbers in order to get the whole 48 bits MAC address. Okay, but in short, in hexadecimal format, the MAC address is written like this. Now, as I said, how do we get a unique MAC address? For 8 crore devices, how do we get a unique MAC address? So as usual, the IEEE, okay, I hate these guys. The reason is they have made my final year project worse. Okay, every time I take my project to the teacher says get it in the IEEE format, and I don't know. Every department has a different IEEE format. Okay, so the I was in EC. Okay, so in the EC, my professor would say check Triple-E's IEEE format. IEEE professor would say check IT's IEEE format. Okay, no one knows what is an IEEE format, but we use IEEE format for the final year. So I really dislike these guys. Even now, I do, because they have set all the standards. everything. We work according to these engineers. We work according to their standards and formats. Anyway, so coming back to our point, IEEE guys, what they said, it's a 6 byte. Okay, 6 bytes or 48 bits. So they said, let's divide this 6 byte into two different parts, 3 bytes and 3 bytes. 3 bytes and 3 bytes. So what they said, the first 3 bytes, okay, we will give you a unique number. Okay, what IEEE said, the first 3 bytes, we will give you a unique number, and that is called as OUI, organizationally unique identifier. Okay, organization uh, organization unique ID or identifier. Okay, and the rest of the 3 bytes is a vendor ID. Okay, so basically what they did is, let's example, I am using a Lenovo laptop. Okay, not, yeah, Lenovo ThinkPad. So Lenovo laptop. So what IEEE said, for Lenovo, the 70B64F, okay, 70B64F, okay, all the Lenovo laptops will start, okay, all the Lenovo, okay, this is just a no, higher, very high view of how MAC addresses are assigned. Okay, but if we go into the technicality, the things may change, but this is just from a higher, very high level view. So what IEEE said, all the Lenovo laptops will start with a MAC address of 70B64F. The rest of the hexadecimal digits or the rest of the 3 bytes, you decide whatever you want. Okay, so you can have 000001. Okay, and it can have any combination. It can have F, A, 0, 1, 2, 3, anything, any combination. But the first 3 bytes will remain the same for all the Lenovo products. Similarly, if you are buying a Cisco products, okay, I hope that all the Cisco products will have the first 3 bytes as the same. The rest of the bytes, the next 3 bytes of all the Cisco products may vary. Okay, they may start, for example, this is just a hypothetical MAC address that I'm writing. They may start as 1, 2, 3, 4, 5, 6. All the Cisco products start with 1, 2, 3, 4, 5, 6. The rest of the 3 bytes, Cisco can assign any value. So that this is how your 8 crores of different products have unique MAC addresses. So my Lenovo laptop will start with 70B64F, but the last 3 bytes will have a different value. Someone else, or probably my family member who's also using a Lenovo laptop, will have this first 3 bytes as same. The last 3 bytes may be different. And this is how you get a unique MAC address across all the devices. Okay. And using these MAC addresses only, your devices, networking devices, can send data to different PCs or different devices. Okay. Any question up till here? Anyone?
Yeah, Laksha, I have a question. So when we say
Yeah.
device to device, this makes a lot of sense. But when we are, fetching information from the cloud or the internet, how will it work? Suppose I am getting information from a cloud network. Again, will it pick the addresses, or the MAC address of the switches or the from or any device in the cloud infrastructure in the same manner?
Okay, first thing, I'm not an expert in cloud, but as far as I think so. I may be absolutely wrong. I may be absolutely wrong. Uh, I don't think you need to fetch MAC addresses from the cloud. MAC addresses are burnt in your devices. You cannot change them.
Okay.
Okay, so whenever your PC or your switch or your router is sending data, it is using the MAC address that is burnt in the device. It's hard coded in the device. You cannot change it at all. So when the data is being
my
when the
question was like,
yeah
if
yeah
we are communicating with a cloud infrastructure, for example.
Hmm.
So when we are fetching some information which is stored on the cloud infrastructure,
fetching some
so how do we
information from
connect? So when we say that we connect to the cloud infrastructure, will it
Hmm.
particularly go, or will it have a gatekeeper kind of thing in the cloud infra, so that we just connect to that gatekeeper switch, or are we fetching the information from the actual node or
Okay.
switch?
So, okay, as far as I understand your question, okay, I'm not speaking from a cloud point of view. I'm just speaking from a data transfer point of view. Okay.
Yeah,
So we are talking from we are receiving and sending data from both sides. Okay.
correct.
So we have a cloud. Basically, cloud is nothing but we call it as a server. Okay. So this is a PC. Okay. And this is a server. Right. So what happens, as I said, this server itself has a unique MAC address,
Okay,
and
yeah,
this PC will have a unique MAC address. Okay. Now, when I am trying to receive or send a data or fetch a data from the server, what I'm going to do, the PC will have a IP, okay, source IP, let's say 1111, for example, okay, and the server will have a destination IP, for example, 10101010, example, okay. Then what happens? The PC is going to create a connection or a TCP connection, okay, with the server on this IP address. Okay.
okay,
Now, what happens is that the MAC address that is being used, the source MAC that is being used here, okay, source IP always goes with source MAC. That will be PC1's MAC address. The destination MAC here would be the gateway routers. Okay, I'll explain IP routing probably later. Okay, but if you understand how routing works, you would
got it.
understand this as well. The destination MAC is the MAC address of the nearest router that is connected. That is the destination MAC. It is never the MAC address of the server.
Got it.
Okay. So then here it will be connected here, and then it is connected to the server. Now, when this data finally reaches this third router, the last router, that router will have a source. IPs never change, MAC addresses changes. At every step, your MAC addresses will change. MAC addresses will change based on the routers or the devices that they're being forwarded. So at this first point, the destination MAC is of R1. Let's, for example, here, when R1 is forwarding the data to R2, the destination MAC, source MAC is going to be R1's MAC address. So destination MAC is going to be R2's MAC address. When R2 forwards the data to R3, source MAC is going to be R2's MAC address. Destination MAC is going to be R3's MAC address. When R3 forwards that data to the server, the source MAC is going to be R3's MAC address. The destination MAC is going to be the server's MAC. The same goes back in the destination in the reverse direction. IP remains the same. The source IP, destination IP remains the same, but MAC addresses changes at every hop.
Okay, got it.
So as I said, MAC addresses are burnt in. You never collect or you never fetch anything from the MAC address. You fetch data through IP addresses, never through MAC addresses.
Okay, got it.
All right. Any other question? Okay. Jay has pointed cloud devices operate in virtualized environment and may have assigned virtual MAC addresses. These addresses are not fixed in the unique or unique in the same way. Oh, okay. So as I said, I'm not expert in cloud. So as I said, I may be absolutely wrong. So, but this is my understanding of how MAC addresses work. Probably give me some time, Monica. Let me see how things work in the cloud side, and probably I'll give you an answer.
No, I got the gist of it, Laksha, when you said, because we need to get to the server, right? What's inside the complete infrastructure should not be of a concern.
Okay, all right. Okay, any question? Because I'm going to stop it here because in the next class we will be using MAC addresses, how devices are forwarding data. That is specifically switch. How is a switch forwarding data through MAC addresses? This is what we are going to understand in the next class. So, but any question for today's? Nothing. All right.